So sorry I can't be there today. I'm stuck at home again, kind of taking care of one of my cats. Um, but you will have already gone over the do now by the time you're seeing this, and so we are jumping right into notes. Now, if you need to pause it here, pause it here, but this is what I want in your table of contents and as your page header 2.09 slope intercept form. All right, so we've talked about slope intercept form a varying number of times depending on what class you're in. Um, And so we've seen it a bit, and I know for a fact that you've seen it last year, right? This isn't totally new to us. And so we're just kind of quickly going to touch on what are the pieces of this and what are we building. Now, in order to talk about slope intercept form, well, we need to talk about two things. One, slope, right? We're going to break this apart. Slope we have talked about quite a bit. We know that m is equal to y2 minus y1 over x2 minus x1, right? And so we also know that slope is going to require two coordinate points. Requires two coordinate points. All right, now let's talk about the other part, right? Because the intercept part, we haven't really talked much. We touched on it very, very little yesterday. Let's take a look at the intercept. And so when we talk about an intercept, in this case, we're going to talk about a really specific one, and we're going to specifically focus in on a y-intercept. Now, a y-intercept is very simply where our line crosses our y-axis. Now, obviously, if we had a different type of intercept, it's wherever the line crosses that sort of intercept. And so, for us, we're looking specifically at a y-intercept. Now, there's something that is always going to be true about a y-intercept. It's always going to be true, and we've actually mentioned it yesterday. A y-intercept always has an x value of 0. Every time. It has to, by design, right? If a line is crossing in a y on the y-axis, that line is always where x equals 0. And so, anytime we see an intercept, we want to look for it by looking for a point that looks like 0 and then some value, right? I'm actually going to call this value not y, I'm going to call it b. And the reason I want to call it b is because I want to make it really clear that when we move into this equation, right, that we've used and that we know y is equal to mx plus b, right? I want to make it super clear here that this b is absolutely the same b. They are one and the same. That's where that comes from, right? Slope intercept form, well, slope intercept. There it is. And so in order to create an equation in slope intercept form, I need two things, obviously, right? I need my slope and I need my intercept. Specifically, it's that y value. Specifically, it's the y value of that y-intercept. And so, let's look at a super quick example, right? If I have the 2 points, 0, 2, and 3, 3. I want to know the equation of the line that passes through those 2 points. Well, first thing I need to do is calculate my slope. And so in order to do that, I'm going to have x1, y1, x2, y2. I'm going to set this up like we have so many times before. 3 minus 2 over 3 minus 0 to learn that our slope is going to be 1/3. And now I need that b value, right? That b value is the only thing that's missing. Well, let's take a look at this point right here. This point has an x-coordinate of 0, which means that 0, 2 is, by definition, our y-intercept, which therefore means that our b value is 2, right? It's that lovely b value right there. And so when I'm going to create this line, it's as simple as plugging these values in. I know that I'm going to have y is equal to 1/3 x plus 2. Simple as that. Pause anywhere you need to make sure that you get all these notes down. These are going to be the only notes that we have in our notebook for today. From here, you're going to go ahead and practice finding